Hi, this is an introduction to the Safely Viewing the Sun lab. I am going to help you through some of the calculations. There's a lot of calculations in this lab, but once you learn one of them or how to do one of them, you should be fine doing all of them because they're pretty much exactly the same. They're just simple ratios. So I'm going to work through one or two examples from each table just to get you started, and then you can fill in the rest. So for what I have right now is part of table 1. Okay, for table 1, you need the measured diameter of the sun and the measured length of pinhole camera. These are the two measurements that you're going to get from your box. This is the diameter of the hole, the pinhole that you're going to determine, and this is going to be the length of the box. So the pinhole camera, the length is going to be much larger, obviously, than the diameter. Okay? We will use this relationship. 1 astronomical unit is equal to 774.7 millimeters. Now this is my value. You will have two different values here, but you will use this relationship to fill out table 1. So 1 AU, astronomical unit, is equal to whatever you have for the length of the pinhole camera. Mine just happened to be this much. Okay, so now that you know this relationship, you can convert these astronomical units for all of the planets into a distance. So how do you do that? Let's take Mercury, for example. So for Mercury, let me use a different color. For Mercury, For Mercury, I will start by the astronomical units that I'm given. 0.39 astronomical units. Then I'm going to use this conversion factor to convert to millimeters. So how do I get rid of astronomical units? I need to have the distance on top, 774.7 millimeters, and 1 astronomical unit at the bottom. This way my astronomical unit cancels out and I'm left with millimeters. And that ends up being 302.13 millimeters. That is my scale model. That's what I'm going to fill over here for Mercury. For Venus, do the same thing, but I have a different number for the astronomical unit. So I'm going to use 0.723 astronomical unit multiplied. This conversion factor does not change. It's going to be the same for all of the planets in this table 1. So I still do the same thing that I did for Mercury. Okay, my astronomical units cancel, and this gives me 560.12 millimeters. Okay, this is how you are going to fill out the rest of the table, table 1, by using your own value for the length of the pinhole camera, but this is the relationship between astronomical unit and the distance in millimeters. Okay, we covered table 1. Now I'm going to show you how to fill in table 2. I have only taken Mercury and Venus here. The rest of the table will be filled out exactly the same as for Mercury and Venus. So I'm just providing you with 3 examples, and then you can follow what I've done here to fill out the rest of the table. So for this particular table, you are provided with 3 different models: the ping pong ball, the tennis ball, and the bowling ball. Okay, and you're given a model size and a distance from the sun. Model size, distance, model size, distance. This is exactly what we were doing in table 1. Distance from the sun, that's the length of the pinhole box, and this is the distance in astronomical units. So we're trying to use, basically we'll use known ratios to calculate the unknown ratios. Okay? So the basic principle here is that if I take the model size for any of these models, but if I take the model size and divide it by the distance from the sun for the ping pong model, that ratio should be the same as the model size for the tennis ball divided by the distance from the sun for the tennis ball and the bowling ball. So let's just work on Mercury and figure out the missing numbers. Okay, so I know for Mercury that the model size 0.17 millimeters divided by the distance from the sun, which is 1.65 meters, and this is for the ping pong ball, should be equal to the model size for the tennis ball, which is 0.37 millimeters, divided by, I don't know this number, so I'm going to call it x meters. This is the distance from the sun. So model size over distance for ping pong ball, that ratio is the same as the model size over distance for the tennis ball. Make sure that you pay attention to the units, because if you don't have everything written in the correct units, you will have trouble when you calculate the distances. So how do I isolate x? The easiest way that I do this type of calculation is I cross multiply across the equal sign, and I set each equal to each other. So what does that mean? I multiply 1.65, go across and up from the equal sign. So 1.65 meters, I multiply that by 0.37 millimeters. And that product is equal to the product of the opposite corners, 0.17, so 0.17 millimeters multiplied by x meters. Okay, now that I have this in a simpler way to isolate x, all I have to do is divide both sides by 0.17 millimeters. Make sure that you carry the units, 0.17 millimeters. Okay, now this cancels, leaving me x meters. This will cancel, okay? And if you were to do this calculation, you should get 3.5. So x is equal to 3.5 meters. So I go up here and I fill in 3.5 meters. Okay. I'm going to erase this, and I'm going to work on the bowling ball ratio, which is set up exactly the same way as we just did. Okay, so we're still working with Mercury. Let's do the bowling ball, okay? I still can keep the ratio with the ping pong, so I can write 0.17 millimeters over 1.65 meters is equal to model size now for bowling ball, 1 millimeter over x meters. I don't know what this is. That's what I'm looking for. So once again, cross multiply and set equal to each other. So I have 1.65 meters times 1 millimeter is equal to 0.17 millimeters times x meters. I isolate the x by dividing both sides by 0.17 millimeters. My millimeters cancel here. The whole thing cancels here, leaving me x. So then to solve for x, if you do that calculation, you should get 9.7 meters. Okay, and that number goes right here. Okay. So how do we go about doing the Venus? That is exactly set up exactly the same as what we just did. So I'm going to do one more example and then you can finish the rest yourself. Okay, so for Venus, I need this number. I don't have the distance from the sun, but I know for the tennis ball ratio or the bowling ball ratio. And so I can start here. I can say 0.73 millimeters over 6.66 meters is equal to the same ratio, 0.33 millimeters over y this time. Okay, cross multiply, set equal to each other. So 6.66 meters multiplied by 0.33 millimeters is equal to 0.73 millimeters times y. Divide both sides to isolate y by 0.73 millimeters. 0.73 millimeters. Okay, and if you do that calculation, y should come out to be about 3.01 meters. So that goes here in this table. Okay, that is how you set up the ratios for table 2.